starknet sequencer just got featured on Bankless. That is really, really important. Let's listen up.
That's something that we're building with Dojo, is a fully on-chain a tool chain for building fully on-chain games. It abstracts a lot of the semantics of like the smart contracts and all this stuff underneath, and allows people to like very concisely and easily build games on top of starknet and take advantage of those properties without necessarily having to be exposed to like the rabbit hole that's usually necessary to understand like a smart contract state model and stuff like this.
So sequencers, they're emerging as one of the most critical pieces of infrastructure in the crypto stack, right? Like A, they're a critical part of centralization in most L2s right now. Two, like many people think they hold the key to solving MEV. Three, they've basically pioneered an entirely kind of business model and flywheel for L2s. In this and following video series, I'll actually dive into sequencers and really try to understand them in depth. The problem with sequencers, though, is that there's very little good resources on sequencer design. Usually they're built by isolated teams of really competent engineers. And so compared to like smart contract writing, there's just a lot less resources out there, especially from a higher level, looking at different architecture trade-offs and so on. I wanted to learn more about sequencers. So how do we fix this? Well, I think the only way is we just take a simple sequencer, an efficient sequencer, and just study it line by line and try to understand and try to generalize from there. So in this video, I'll provide an overview of the katana sequencer specifically, which is part of the Dojo toolchain, and it's designed to be an incredibly fast sequencer for gaming, for on-chain gaming type applications, right? In Bankless, they actually talk about this as starknet's on-chain gaming oasis, right? As really the best place to build on-chain games, and Dojo is featured very heavily in that, and katana is basically the sequencer that underpins Dojo. So right here we see Dojo is a provable game engine built by the starknet on-chain gaming community, led by Terrence of Cartridge, right? And with all these like provability properties. So after that, I'll actually go through the repository. Let's do it together and try to understand how it works outside in. And then we'll just recap and summarize what we've learned about sequencers and kind of this unique implementation. It's a very unique part of the trade-off space. Before we do start, I just want to quickly take some time to explain what is a sequencer, right? So sequencer basically provides a fast path to send transactions to an L2, right? So every L2, you can always send transactions through the L1 smart contract, and that's a good backup plan, a good way to get money out, for example. But usually you'll send it to some sort of third-party service, which actually is the sequencer. Like if you use an L2 like Optimism or Starknet, you are basically using a sequencer there. Sequencers are increasingly isolated from like actual block building and block execution, and kind of what they do is in the name. They basically is a service that sequences transactions, that defines the final ordering of transactions in a block, right? Sequencer has the full authority to try and reorder transactions whichever way they like. And they're incredibly important, right? For that reason, first of all, sequencer revenues are how L2s make money today. These are kind of north in the millions and could be a lot bigger if block space gets more saturated. Sequencers cannot forge transactions, so we can kind of cope with their centralization in the short term, and especially for use cases like gaming as here. But long term, we need to decentralize them because they can obviously manipulate transaction order and extract MEV that way. So even though they can't forge transactions, ordering is still very powerful, right? And then third, sequencer performance is closely tied to network performance, right? L2s are improving their throughput, are reducing their latency, and a lot of that comes down to efficient sequencer design. And there's kind of two parts of this, right? There's this sort of high-level aspect, which is sequencer architecture, right? Are you using a single centralized sequencer service that you point to, or are you using maybe a decentralized sequencer or shared sequencer between multiple rollups? So that's your architecture. And then you have sequencer services, which plug into that, right? So if you're using a single sequencer, like what's the actual sequencer service? Like who's running it? Who's operating it? What does the code look like? I really want to dive into this problem because I think if we understand sequencer services, we can then start understanding sequencer architectures, but not the other way around. So let's dive in. This may take a while, so I have my Twinings Earl Grey milk tea here. Really, really recommended. This is the OG. If you want to just pause the video right here, grab some coffee and tea, we're just gonna start diving in here. So, all right, so First, like what is Katana? What is Dojo? Right? Really, really quickly. Dojo is a provable game engine. It kind of has a bunch of different tools to build on-chain games. We're here in the repository. You can take a bigger look, but it's sort of basically, it's kind of like a game engine for on-chain gaming, right? There's not a one-to-one mapping of what a game engine looks like for smart contracts, but it basically has, an indexing tools. It has like Katana, which is the sequencer, and then it has like tools to kind of look at your game state and observe that and monitor it. It has like SDKs and so on. So it's really tailored to build these kind of more sophisticated anti-component systems that games demand. But we're particularly interested in the Katana sequencer, right? I think it's a great, fast, centralized sequencer which will teach us a lot, even if we're not looking to build games, if we're just looking to build very efficient sequencers. And kind of where does it lie in the sort of architecture space? Well, I think Terrence did this wonderful tweet kind of outlining the anatomy of gaming sequencer, what Katana is trying to be. Centralized by design, so very fast. Instant transaction inclusion, so low latency. Delayed state root computation, so very high throughput. So state root computation is basically kind of a safety mechanism, it's just like how much trust do you want to place in that. And then there's a spatial storage representation which allows kind of efficient querying on the indexing side and data availability side. There's a secure enclave support, so you can have hidden information in transactions in games. And then it's obviously ZK, state diff based, which because it's using starknet and you have kind of validity proofs, you get some of these other kind of benefits. Yeah, so I don't know what half these concepts really deeply mean, and I'd love to kind of actually just get into the code and understand it. So why don't we just do that? So Dojo has multiple crates. The one we're interested in is the Katana crate. So let's see. All right. So I think basically Katana kind of combines a sequencer, but then it has obviously this sort of RPC API. That's what ends up, if you're using, like, if you're running a Dojo sort of test net, I think you're going to be running basically a Katana node locally, and you're going to be using kind of these RPC endpoints. So I think that's why we're seeing that here. But yeah, I don't know. I'm assuming that some part of this, so a sequencer, there should be some part of this which basically tackles transaction ordering. So I think the goal for this video basically to like, can we find that part, right? So let's look and see if there's any tests. Ooh, we have some tests here. So okay, let's dive in. Sequencer, there we go. All right, so that's a good start. All right, so let's see how we can use Katana. So we can create a sequencer configuration, right? So this kind of looks very familiar to just generally building a node, right? If you're a smart contract developer, you'll be familiar with like spinning up a local test node of Ethereum, right? You have some accounts. You have, I guess you're disabling the fee here. There's some environment context. This all resonates. So then we create the test sequencer. All right, Katana sequencer. So we're going to want to look into this. So Katana core, Katana sequencer. Okay, let's remember to go back here. All right, so what tests do we have? So we create a sequencer. We mine an empty block. So again, so far just using it as a node. And then we get the block timestamp. So we get the backend blockchain storage. We can read. Okay, so basically it's kind of like showing an RPC API, right? Next block timestamp sequencer backend mine empty block. All right, so basically checking the RPC API. That makes sense. Next block timestamp in the future. So this is interesting. Okay, so the sequencer, we can also manipulate it, right? So this is cool. I guess for testing purposes, you may want to control the timestamp. That's fine, especially building games, right? You want to fast forward. Increase next block timestamp. Yep. Set storage, add on instant mode. Okay, so you can control storage. So in starknet, the basic storage element is not a uint. It's a felt or bytes 32. It's actually a felt, which is very similar but slightly different. Doesn't matter, but that's why you can see that here. Dump and load state. Okay, so this is cool. We can snapshot our state. Let's see if there's anything interesting here. Okay, so we're adding a declare. So declare transactions in starknet basically is a way to deploy a contract proxy, right? Or a contract kind of clone proxy, where you first declare the contract and then you can deploy versions of that contract, right? Just a bit more efficient. So nothing crazy there. Right, and then you can kind of access transactions. All right. New sequencer with a serialized state. Okay, so then you can spin up a new sequencer and basically recover the state. So this is pretty cool. If you're testing a game, maybe you're building up some sort of like complex on-chain state to initialize the game. Could be also good for simulations. So then you can just snapshot that state, dump it into a file, and then in your CI you can just recover from that file, and you're like right there. Oh my god, I would have loved this when kind of early days in building on starknet. I would have actually loved this feature, but right. So okay, so these are like very sparse tests, just testing basic endpoints, right? Testing kind of creating blocks. All right, so basically testing here kind of, I want to say more node functionality. So we're not going to get a lot out of the test. I think we just got to go straight for that sequencer. Right, is this where it's going to be? Katana. Sequencer. All right. So what is a sequencer here? So we have some config, right? We have a transaction pool. So this must be the mempool, right? Just transactions being sent to us. The backend, I'm guessing the backend kind of similar to Ethereum must be some way of thinking about state, but more, I guess, block state, block timestamps, things like that. Let's see that we have the block producer. So I wonder if it's fair to say if that katana is also a block builder built in. I don't know. Looks like it. Again, I don't know anything about sequencers, so we're learning this together. All right, so let's see. So creating a new sequencer. We create a backend. We initialize transaction pool. We create a transaction miner. Okay, so this is cool. This may be where the ordering part comes in. So I may want to actually dig deeper into that. And we have the listener. So I'm guessing listener is going to be some way of listening out for transactions in the sequencer. We have the block producer. I think I'm not going to focus on that because usually it shouldn't be part of a sequencer. Maybe you know, kind of in the modular view of the world. These are all separate things. Okay, and then if we have no mining, then it's basically saying transaction should be kind of mined on demand. Is that what it is? Potentially, okay, we have some sort of messaging service. And then we are, oh, okay, this is where we're creating the actual node service, right? So we have this pool block producer, and I'm guessing this is where it starts to listen out for these transactions. All right, what else is there in the sequencer? Pending state, block producer, okay, we don't care about that. Verify contract exists, I don't care about that, I think. Okay, then we have state. So what goes into state? Okay, so it's the block ID, right? So we're just basic things about, again, this is probably more relevant to the block producer, I'm guessing. Okay, add deploy account transaction. Okay, so these are basically, right, these are going to be some of the RPC endpoints here and ways to send that. Oh yeah, okay, so we're sending that transaction to the pool. This makes sense. So these are just endpoints for you know, outside submitters to send transactions to the pool. That's fine. Yep, estimate fee, block hash. Yeah, so these are kind of typical RPC endpoints here. Storage at, yep, chain ID, block number. So full on RPC API, right? We're just getting all that from the back end, right? Just as I said, all the state should be in the back end. Very cool. Cool. Okay. Transaction. Interesting. What is this? Is this looking up a transaction? Probably. Yeah. Blocking storage, read transactions. Yes. Right. So then gets the transaction by hash. Fair enough. So yeah. Okay. So we have kind of the full RPC API here. I don't want to go through too much detail here because we sort of know how that works, right? If we've seen an RPC node, Geth, if you've read Geth code, you'll see all these endpoints. That's fine. What I'm interested in is the I think I'm interested in the transaction pool. I'm interested in seeing like if there's anything cool there. And then I'm interested in the transaction miner. I think these are the two components that would be really interesting. So like, how is the pool looking at maintaining transactions? Is it just like some sort of simple queue? Is it just like a set? Whatever that is. And then the transaction miner specifically. So, all right, so let's see. So transaction pool is in the pool crate. And then where's the miner? All right, the miner's in the service. Okay, so service and pool crate. Right, so let's start with the pool, since it's just a single file. It looks like it's a very short one. Okay, so transaction pool. All right, transaction pool. We create a new one. We can send transactions. All right, self transactions. Okay, so this is really simple. It's basically writing that transaction and notifying listeners, right? So the pool, right? So you can have listeners. That is interesting. So it's kind of a more synchronous design. Notify listener about the transaction. So you just go through all the listeners, and then how are we telling them? Try send. Okay, we're basically we try to send them the transaction. That's pretty cool. Okay, fine. Okay, so pools are pretty easy. I guess they're just. It's really a very lightweight abstraction. Let's look at the miner. So, where is the miner? Okay, right here. So, takes the transaction from the pool and feeds them to the block producer. Right. Okay. So, are there pending transactions? And then receives hazardous transactions that are ready from the pool. Interesting. Okay. I'm curious. Yeah, I guess I don't fully understand. In terms of pending transactions, okay, I guess this just means, does it have any, because I guess pending means that it hasn't been assigned to a block. So I'm guessing then it's kind of temporarily here. Okay, so what does it do? So we create it, initialize it, doesn't have pending transactions initially. And then what it does is it can poll. So it can poll the pool, right? So it can ping the pool and say, hey, any transactions, right? So it polls the next. And then if there, okay, if it, yeah, I can find a transaction, then it will say that there's a pending transaction now. Otherwise, you will say that there isn't a pending transaction. Take all the transactions from the pool. Okay, so it just gets all the transactions from the pool and then just mark them as ready. Okay, so there's no ordering here. Is the ordering then in the block producer? That's what I'd love to find out. Node service, block producer. Block producer, okay, yeah. That is back here. All right, we're gonna find it. There we go, instant block mining future. Okay, so that may be basically just like instantly mining a block on every transaction. That could be the case. All right. So block producer, what can it do? So create a block producer that mines a new block every interval milliseconds. Right, so just take whatever transactions it has received and it'll mine a new block. That's fair. Okay. Then we have on demand. Create a new block producer that will only be possible to mine by calling the katana generate block. Okay, so this will obviously allow the user to sort of figure out when to push out a block. Instant means not new block as soon as they're ready transactions pool. Right. What is this queue? So we take the transactions and then we get this mode variable. And so it's either instant or interval, okay. And then it will just do the same thing. Okay, that's interesting. So independent of the mode. Okay, I guess, so what that means is like, if the mode is instant or interval, but not on demand, right? So basically, if the mode is not on demand, then we can queue the transaction, because on demand, I guess that we don't have control over that. Fine is returns true to is running in interval mode. Okay, yeah, this is just pinging for the mode. And then force mine. Okay, so this is how you force the mining. Sure, when the on demand mode. Yep. Okay, block on. Yep. Poll next, interval block producer. Okay, so then we have the state of the pending block. All right, interesting. So now we may be getting into the meat of this. I just want to check back how, so if we say interval, then, we're creating a new interval block producer. Okay, so realistically, I think this is the one we're interested in because this kind of most closely matches how a sequencer would work, right? So this is the one where I think we're interested in. So interval block producer. All right, let's see. So what's the state of that? So the interval which new blocks are mined, fine. Backend, yep. Single active future that mines a new block, right? So this is the actual computation, that asynchronous computation. Backlog of sets of transactions ready to be mined, right? Okay, we're maybe getting at the ordering here. Right, queued. That would be very interesting. State of the pending block after executing all transactions, fine. I don't care too much about the block state. So make sure the block context is updated. All right, interval block producer, yes. Boom, boom, boom. Initialize it. This is the constructor. State, execute transactions are empty. Fine. All right. Then you could create a new one with no interval. This mode will not produce blocks for every fixed interval, although it will still execute all queued transactions, keep all the pending state. Okay, we don't care about this. Force mine a new block. All right, so we can force it. All right. So then do mine. I wonder if this is the thing that actually, Safari. This is the thing that'll actually be used. Creating a new block, mine pending block, okay, update block context, executed transactions, okay, execute transactions, right, this is interesting. So this is basically mixing the execution layer, I guess, a little bit with the sequencing, that's fine. All we care about is to find the sequencing. Transaction executor, okay, research as long as the map, okay, execution info. So it's going one by one through the vector of transactions and then execution, okay. So that's fine, I guess. Like this may be actually happen when we already have the block produced. Execution outcome, did a state diff declare, that's, okay, this is just seems like some maybe form of derivation here, okay. Implement stream for interval block producer. Nice. Cool. So stream makes sense. I guess this is a way to, it's seeing the block producer as a stream of blocks, I'm getting. Yeah, mine block outcome, right? So stream is basically an asynchronous set of items just coming out. Poll next, right? So this is how we can, I guess, lock and wait on the next item, which will be a new block. Let transactions. All right, so transactions queued. All right, so this looks, yeah, so basically these transactions are just gonna, yeah, so basically this is the loop, right? So if there's, if the queue is not empty, if there's transactions in the queue, then we shall get the first transaction sequence or first transaction batch. So I'm going to execute that, and we're going to keep doing that. Yeah. So I guess the interesting thing is, like, in all these situations, the queue is not a direct sequence of transactions. It's almost like a sequence of sets of transactions. But effectively, I don't think that changes things. I think what we're actually seeing is this is like a very simple first in, first out sequencer, right? Yeah, it's just because I think we have here the sequencing combined with the execution and the block production. So this is like a very compact view of the kind of L2 universe, right? This is a very clean node that sort of does all these things. Yeah, so it's not using, it's not like abstracting about sequencing logic. It's just using a very simple kind of first in, first out sequencer. But it's really nice. I mean, okay, so is there anything else we want to look at here? I think we just got there pretty quickly. I'm actually surprised. I thought it would be a lot more tricky, but we got there. So let's just step back and see if there's anything else interesting. Messaging, I think I'm not too interested about messaging, but obviously it has to sort of be able to communicate back to the, I think in this case, Katana is like meant to be deployed on starknet as an L3. So I think in this case, there's both communication to starknet and maybe to L1 Ethereum, which is very cool. What are some other aspects? yeah, I'm not too interested in kind of the database details because those are probably very similar to how just like starknet handles it in general. Obviously execution and all that stuff. Yeah, no, this is great. Backend would just be like storage and state and contracts. Yeah, so I think it's a very very nice. I mean, I think we did it. I think we understood like basically a very simple sequencer plus block producer plus kind of some execution, I guess. A full effectively node that you can use for games. And I think really just the perfect starting point for a sequencer journey, just really the simplest possible example and seeing like, okay, this is where the transaction sequence basically comes in. Yeah, you can use first in first out with a queue, but obviously there are a lot more interesting methods. And this is also where if the katana sequencer was malicious, we would be seeing some different pieces of code, right? Maybe they'll be looking for some MEV opportunities or so on, and trying to like understand and actually analyze what's happening in the transactions. In this case, like it's a fairly straightforward first in first out. Where whichever transaction comes first in the pool will just plop onto the queue, and then also be the first out, right? So really, really simple. All right, so I don't know, what have we learned? I think we've learned how sequencers fit together into the overall landscape through this example. Second, we've seen that basically maybe efficiency just comes from simplicity. I think Katana is a very fast sequencer just because, and it's like it was so easy to just dive in and understand exactly how it works and how it fits in, and you can see the modularity, right? Like we could have had a different pool handler. So we could have had a different transaction miner, which is probably a way that we can actually modify the sequencer. So you could take the system and like plug and play modify it, and start thinking about how to like build your own sequencer or L3 out of this system. And yeah, I think I'm excited to dive into more complex sequencers next, and see how we can generalize those learnings. But basically, yeah, to make an efficient sequencer, just keep it really simple. If you want to keep learning more about sequencers, subscribe to this channel, and I'll continue next week with this series. It'll be pretty cool. Thanks for watching, and also check out Dojo on the internet as well. Look at GitHub. I think they are a very exciting project that needs more attention. See you next week.